Students, in this session, let us study about center of gravity, which is one of the properties of a solids. So here in this session, we will study how to determine the center of gravity of simple solids and composite solids. Simple solids in the sense cylinder, cone, sphere, hemisphere, etc. And composite solid in the sense combination of these simple solids, and how to find the center of gravity for these solids. So these are all the values of x bar and y bar for the simple solids. So first, cylinder. For a cylinder means it's a three-dimensional object. So this image is a pictorial view of the cylinder, and the base will be a circle, right? And it has height also. The cylinder having base circle diameter as d and height as h. For this cylinder, what is x bar? X bar value is d by 2 and y bar value is h by d. X bar means this centroid G, where it is located. Where this centroid G is located with respect to this x-axis and y-axis. That's all. That means x bar distance means this distance. See this image, see this line, see this. So this is x bar, this distance along x-axis taken from y, this distance. So this will be the center point of this, okay, d by 2. So total length is d, so up to the midpoint it is d by 2. Then y bar in the sense height, okay, see this height. This height is from along y-axis taken from x-axis. This height is y bar. This height also at the middle of this height by 2. And we know the formula to find the volume of the cylinder is pi r square h. Okay, then for a cone, it's a three-dimensional object having circle as base and height apex point also there. So G is located. So G means x bar and y bar. This is x bar and this is y bar. This is the volume. Volume is 1 by 3 into pi r square h. And this x bar value, so I didn't draw the diagram for your simplicity. X bar means this distance, likewise this distance, and y bar is the height. So the same, we find x bar and y bar. Y bar value is h by 4. This is not triangle, this is a solid figure. Where triangle means it is h by 3, but it is a solid figure. Cone is a solid figure, it is h by 3. Don't confuse it. Then sphere, we know the diagram. Sphere, spherical shape. For a sphere also, the x bar value is d by 2, y bar value also d by 2. The formula for volume is 4 by 3 pi r cube. Then hemisphere, half portion of the sphere. So here also d. The height value is 3 r by 8. This is somewhat different value. And the area of the hemisphere is 1 by 2 of the sphere. That is 2 by 3 of pi r cube. Okay, let us solve one problem. Okay, let us solve one problem on this. So this is the question, it is given. So here the diagram won't be given. Just the question, we have to read and draw the diagram. Okay, few problems diagram will be given, but some problems diagram may not be given. So here in this problem diagram is not given, we have to draw a cylinder of height 10 centimeter. So it's a cylinder, okay, cylindrical shape. A cylinder of height 10 centimeter and radius of the base, radius is 4. So diameter means 8 centimeter. Placed under the sphere. So the cylinder is under. So sphere is on the top of radius 4, such that they have a common vertical axis. So it has a common vertical axis. It has, so if both of them are made of same material, locate the center of gravity of the combined unit. So here in this they are explaining about homogeneous material, because for heterogeneous materials the density also differs, but for our problems they will give only the homogeneous solids. So here let us solve the problem. So here in this, for finding the x bar and y bar, okay, here also we use volume. So we use volume. So in centroid we use area, a1 y1 plus a2 y2 by a1 plus a2. But here for solids, we instead of using area we use volume in the formula v1. We have to find the volumes of the sections. Okay, volume for a sphere, the volume is 4 by 3 pi r cube. We already studied, right? For a sphere the volume is 4 by 3 pi r cube. For a cylinder it is pi r square h. We will use that formula to find the values of volumes. Then after finding the values, we need to find the centroidal point. So here also we choose the reference axis as like horizontal axis and vertical axis. We have to choose the left side x, y, and the bottom post will be the x axis. Then I choose this as the first section and this as the second section. So first is cylinder, second one is sphere. So center point, centroid of the individual sections. So this is first centroid of the cylinder. Then this is centroid of the sphere, G2. Okay, this is G1, the centroid of the first cylinder, and G2 is the local centroid. Then x1, this distance. Okay, x2, this distance. Both are same, because these two will be in common vertical axis. So these two have common vertical axis. So x1 and x2 will be same, and also it is equal to 4. It's a midpoint. Total is 8. So midpoint means 4. x1 and x2 will be 4. Therefore x bar value also 4 centimeter. Okay, then we need to find y1 and y2. Then we can solve y bar. For y1 means, what is the distance? Means this distance, isn't it? y1 means this distance. This distance is y1. What is the value? So total is 10. So it will be the midpoint. 10 by 2, that is 5 centimeter. Then y2. y2 in the sense up to this distance, right? So we have to take it from x-axis up to this g2. Isn't it y2 value? This y2 value, what is this value? So we have to add 10 and something, right? Okay, so here up to this 10 centimeter, then this is the midpoint, r, radius value, r. So we have to add 10 plus this radius, 10 plus this radius, 4, which gives 14 centimeter as y2. Okay, we have to add 10 and this radius value, then we will get y2. So we got all the values. Then we can substitute in the formula, y bar formula, v1 y1 plus v2 y2 by v1 plus v2. We will get the value of y bar as 8.13. So we got x bar as 4 centimeter and y bar as 8.13 centimeter. That's all. Then let us solve another problem. Okay, this is the problem given in the question. So here figure also given in this problem. So locate the center of gravity of the bullet. So they are giving on composite figure. Bullet 1 centimeter diameter. So diameter will be 1 centimeter, and with a cone with the front. So diagram is given. Okay. So here one cone is there, one cylinder. So this figure. So how to solve this? First, what are the solids here available means, first it has a cylinder. Okay, it has a cylinder. The composite figure has, okay, so this is the image given. Only 2-dimensional image will be given, but this object is a 3-dimensional one. They will give only the 2-dimensional view. It's a cross-sectional view in the middle. Okay, in the axis, cross-section of the axis only given, but the object is a solid only. So here what are the parts available? So here 3 parts will be available. First is one cylinder is there. cylindrical shape, and on the top of the cylinder it has a cone. So that's why the question is given. A cone is there, and and a hemispherical shape. Hemispherical shape is cut, which is removed. This is how the object will be there. Okay, this is how the object will be there. So here we have a cylinder, and on the top we have a cone, and at the bottom a hemispherical shape which is cut. So this is the final image they are given in the question. So let us draw the 2D diagram of this. 2D diagram of this image. So this is the 2D diagram. So here on the top, one cone, one cylinder, one hemispherical shape is cut. Then I use first section as this cylinder. Cylindrical part is section 1, and this triangle. This is not the triangle, it's a cone, is a section 2. Then removed section is section 3. So the formula becomes V1 y1 plus V2 y2. So first and second will be added. From the 1, 2 is added, 3 should be subtracted. It is removed section. So minus V3 y3. So here minus V3 is there. So here in this, let us find the volumes first. So volume of the cylinder is, so first section is cylinder, pi r square, guys. We can substitute the formula, we will get. So here radius is, so totally the length, the diameter is 1 centimeter. What is the radius? 1 divided by 2, so 0.5. 0.5 centimeter into height value is 2.5 centimeter. We will get the value of volume of the cylinder. Then volume of the cone 1 by 3 into pi r square, right? So r is same 0.5, and height of the cone is 1 centimeter. Then V3, that is volume of hemisphere 2 by 3 into pi r cube. So radius is 0.5. We will get the values. Then we have to find x1, x2, x3, y1, y2, y3. Then we will find the answers. So here the local centroidal point. So this is the G1. This is G1. G1 means the center point of this cylinder, first section, center of gravity point of the first cylinder. Then G2 is a center of gravity point of second cone. Then G3 is the center of gravity point of the hemisphere. G2. So G3. So after this, what we need is, we need to find x1, x2, x3 and y1, y2, y3. So what is x1? So this distance is x1. That means 1 divided by 2. 1 divided by 2, that is 0.5 centimeter. So x2 also and x3 also. So these three are same because the solid is symmetrical about the vertical axis. So these three are same. x1 and x2, x3 are same, which is equal to 0.5. Therefore x bar also same, 0.5 centimeter. Without calculation we can do it. Then y1, y2, y3. Y1, y2, y3. First we will find y3 value. This is y3, right? y3 means the vertical distance of G3 from x, right? So this value. So this value is the formula. From the formula we know that y value is y3 value, isn't it? y3 value is formula 3r by 8. So this is the center of gravity point of hemisphere. y3 value is 3r by 8. We have to study that. 3r by 8, this value. This is not circle. If it is a circle, it's a two-dimensional object, it is 4r by 3 pi. But it is not the circle, it is a solid. Solid. So here y3, this value is given as 3r by 8. We have to multiply radius, 3 into radius 0.5 by 8, we will get 0.185. Then y1, this distance, y1, this is the midpoint, isn't it? Cylindrical shape, 2.5 by 2, 1.25 we will get. Then y2 value, the total distance, isn't it? So up to this, the value is 2.5. Plus this height, what is this height? We have to find this height. This height is h by 4, total. So So we need to find y2. So this y2 is up to this distance we will get. Okay, from the exercise we have to find. So this distance, what is the distance? We have to add 2.5 plus this h by 4. This distance is h by 4. So for triangle only it is h by 3, but it is a cone, it is h by 4. Okay, 2.5 plus 1 by 4 into 1 by 4. Okay, we will get 2.75. So we got all the values. Then we can substitute in this formula. Okay, in this formula we will get the value of y bar as 1.59. So x bar value is 0.5 and y bar value is 1.59. So this is the global centroid of the composites section. Okay, this is a G1, G for the total G. So G. So we draw x horizontal and vertical axis, which are, what is that? Which are centroidal axis, x axis and y axis. So this is x bar value. X bar value is 0.5. This is y bar value. Y bar value we got it as 1.59. Okay, we got the answer.